Bismillahirrahmanirrahim. Welcome to the second part of 13th lecture of statistics and probability theory. We will continue with the topic multivariate hypergeometric distribution. Example number 2. A foreign student club lists as its members 2 Canadians, 3 Japanese, 5 Italians and 2 Germans. If a committee of 4 is selected at random, find the probability that we have two parts in this example. Find the probability that all nationalities are represented, and the second part is find the probability that all nationalities except Italians are represented. So here we have n is equal to 12, capital N is 12, as we have 2 Germans, 5 Italians, 3 Japanese and 2 Canadians. So 2 plus 3 plus 5 plus 2 is equal to 12. And so here we can see that capital N would be equal to 12. And we are selecting a committee of 4 members. So this is the small n, as you are selecting 4 persons from 12. And what you have to do, you have to name the categories. A1 is equal to Canadian, A2 will be equal to Japanese, A3 will be equal to Italians, and A4 will be equal to German. So A1 will be equal to 2, A2 will be equal to 3, A3 will be equal to 5, and A4 will be equal to 2, as you can see from here. So here it is written that find the probability that all nationalities are represented. So if you say that you have to represent all the nationalities, that is Canadian, Japanese, Italian and German, and you are selecting a committee of 4, so it is obvious that you will select 1 Canadian, 1 Japanese, 1 Italian and 1 German. So we are associating the random variable with each category: x1 with Canadian, x2 with Japanese, x3 with Italian and x4 with German. So all the nationalities are going to be represented. So it is obvious that x1 would be equal to 1, x2 would be equal to 2, 1, and x3 will also equal to 1, and x4 will be also equal to 1. So according to the probability mass function of multivariate hypergeometric distribution, it is x1, x2, x3, x4, A1, A2, A3, A4, as these are the parameters of multivariate hypergeometric distribution, will be equal to A1, see x1, 2, Cx2, A3, Cx3, A4, from which X4 elements are selecting, whole divided by n small n. So as you know, x1 is equal to 1, x2 is also equal to 1, x3 is also equal to 1, and x4 is equal to 1, a1 is equal to 2, a2 is equal to 3, a3 is equal to 5, a4 is equal to 2, and capital N is 12 and small n is 4 will be equal to 2 C1, and by substituting all the values as a1 is equal to 3, a1 is equal to 2, a2 is equal to 3, a3 is equal to 5, a4 is equal to 2. So you will get the probability of selecting all the nationality members or the members of each nationality in a committee of 4, which is 0.1212. Whereas in part number B, it is asked that find the probability that all nationalities except Italian are represented. So what they are saying that this Italian should be not in the committee of the 4 members. The committee should be constituted on the basis of the members from Canada, Japan, and Germany. So what could be done here? There will be 3 cases. The first case would be that as you are selecting the committee of 4 members, so the first case would be that you select 2 Canadian, 1 Japanese, and 1 German. Or you can select 1 Canadian, 2 Japanese, and 1 German. Or you can select 1 Canadian, 1 Japanese, and 2 German. So you can make the committee of 4 members by any of these 3 ways. Committee could be like case number 1, or it could be like case number 2, or it could be like case number 3. So the probability that all nationalities except Italian would be represented will be, this is the case that 2 Canadians are selecting and 1 Japanese. 5C0 means you are not selecting any member from Italian people. And here you can see 5C0 is representing, as it is saying that you are not selecting any Italian in the committee. So here you are selecting 2 persons from Canada, they are Canadian, 1 from Japanese, and 0 from Italy, and 2 from German people. Similarly, this is the second case. 1 is Canadian, 2 Japanese, 0 Italian, and 1 German. And this one is the third case. 1 Canadian, 1 Japanese, 0 Italian. It is no one is selecting, and 2 German. So by simplifying this, you will get 0.0484. So this is the probability of making the committee of 4 members, which is representing all the nationalities except Italian. Example number 3. An urn contains 3 green balls, 2 blue balls, and 4 red balls. Here you have an urn in which you have 3 green balls, 2 blue balls, and 4 red balls. So they are total 9 balls. So this 9 will be equal to capital N. And what they are doing, they are taking a sample of 5 balls. So this is the small n. They are taking or selecting 5 balls, and what they are saying find the probability that 2 blue balls and at least 1 red ball are selected. So here you can see that n is equal to 9, small n is equal to 5. A1 is representing the blue color, A2 is representing the red color, and A3 is representing the green color. So A1 will be equal to 2 as you have 2 blue balls. A2 will be equal to red as you have 4 red balls, and A3 will be equal to 3 as you have 3 green balls. So here is the solution. They are saying that find the probability that you are selecting 2 blue balls and at least 1 red ball. As you are selecting 5 balls from the urn containing 9 balls, so what you can do, you can select 2 blue balls as it is obvious and 1 red ball. This is the case that you have 3 balls selected and you have to select the total 5 balls, so remaining 2 will be green balls. But as it is said that you have to select at least 1 red ball, so this one is the lower limit. You can go as far as the scenario allow you, as we have already discussed this case in previous lectures, that at least is the minimum limit, that minimum you should have 1 red ball in the sample of 5 balls which you are selecting from the urn containing 9 balls, and there should be 2 blue balls too. So you have selected 2 blue balls, 1 red ball, and remaining 2 are green. Or you can do it in this way, that you can select 2 blue balls and 2 red balls, as they are saying at least 1. So you can go further selecting the 1 red ball. So you can select 2 red balls too, but here the count is still not complete because you have to select 5 balls in total, and here 2 plus 2 will be equal to 4. So you have to select 1 more ball from the urn to complete the sample of 5 balls. So remaining 1 will come from the green balls. Or you can do that you can select 2 blue balls, 3 red balls. Now what happened there? Here you have to select 5 balls in total, in which 2 must be equal to blue and at least 1 should be red. So what you did, you have selected 2 blue balls and 3 red balls. So the count is complete here. No need to select any green balls, as you are taking the sample of 5 balls. So this was the scenario that you have to select two blue balls and at least one ball. So this particular experiment could be done in this way. This is the case number 1. By selecting two blue ball, one red ball and two green balls, or this could be done in this way by selecting two blue balls, two red balls and one green ball, or this could be done in this way by selecting two blue balls, three red balls and 0 green balls. So by applying multivariate hypergeometric distribution probability mass function, which is this A1 Cx1, A2 Cx2, up to so on how much categories you have. Here in this particular example, you have 3 categories. This is A1, this is A2, and this is A3. This is X1, this is X2, and this is X3. So this one is capital N and this one is small n. So here you can find out the probability of selecting two blue ball and one red ball and two green ball. Here you can find out the probability two blue ball, two red ball and one green ball selection. From here you can find out the probability two blue ball, three red ball and 0 green ball. On adding all three cases, you will get the probability of selecting two blue balls and at least one red ball, which is equal to 0.2698.